Okay, guys. Today I will show you how to prepare to visualize a gridded area with different resolution. So sometimes when you want to prepare your presentation, you want to show that, for example, here we have a coarse resolution of CMIP 6, high resolution of MIP, and we do downscaling because there is different resolution of this dataset. So what we want going to do is how we want to visualize just for presentation purposes, uh, how the coarse resolution of CMIP 6 looks like. It looks like this. You see, if we use the coarse resolution of CMIP 6 with 2 by 2 degree, it will only capture 6 grid point. So CMIP 6 is a global dataset. It's a very coarse resolution. And some of the CMIP6 dataset is have high resolution, and they call it high resolution MIP, and it has down to 0.25 degree, and it looks like this. So it capture more area in the Peninsula Malaysia, and I believe it capture about 173 grid point. But if we further downscale this dataset by using regional downscaling or statistical downscaling or hybrid downscaling, whatever method that you do, you can further downscale it into 0.05 degree resolution, and it's look more finer. So just for the purpose of your, when you want to make a presentation to tell the people that projected data of CMIP6 looks like this, it's a very coarse data set with 2 by 2 degree, and then high resolution MIP with 0.25 degree, and uh, downscaling, you can further downscale it into 0.05 degree. So now we want to prepare this grid. So let me show you the code that I have prepared. So first we prepare 2 degree grid. So for these purposes, we need like our packages for lattice, raster, and raster base. So you can install this install these packages by using install packages, and then lattice. If you still not install it, so you can use put raster or raster vis here, and then install all of that packages. So you can install. So I'm already installed these packages, so it will not install anymore. Let's see. Let me check for raster. Sometimes it will reinstall the packages because there is some update for that packages. You see, all the packages is no update for the packages, and it is still as it is. So you don't need to install that packages anymore. You can just load that package library, that packages by using this library function. So you run this library, raster, and raster vis. Now you set your working directory where you put your DEM dataset. So we don't want to just put the grid, we want more information, like in this map I show you just now. I have study area, and I want put it in DEM so that it will look more informative. There is elevation areas, low elevation area, high elevation area in this area, in this study area in Peninsula Malaysia. So I go to the working directory, which is a folder address for your research where you put your DM dataset. So my folder address is D research trend rainfall Penang and DEM. So my DEM is in TIFF file, DEM. So this is my dataset in this folder address. So you can run your working directory just now and then run your DEM. Now I will create a 2 by 2 degree grid resolution. First, we extract the extent of the DEM. We have this DEM file just now. We use extend function. to extract the extent of the DAM. And then we generate a 2x2 degree grid based on the extent. So by using raster, extent will be resolution is 2x2 here, 2x2. So we use the same CRS as the DAM to make sure that the projection will be the same. So we run this one. And then we populate the grid with dummy data to create visual boundaries. So value grid is 1. We create a dummy data. Convert the grid to spatial polygon object for visualization. So as grid 2x2 just now by using spatial polygon object. And then now we plot the DM and overlay the 2x2 degree grid. So we use plot function here. So plot DM with 2x2 degree grid. This is the title of the map. And then terrain color, which means the color of the terrain will be, we are using 100 here. And then we plot a grid polygon and X2 border is red with 1.5 thickness. So that means we plot the DM and then overlay it with the grid. So as you can see, it will produce the DM, only the DM first, and then we plot the grid up on it. So let's see, okay, as you see, the grid is there. Now we put the coordinate. This is only optional. We add grid labels. We add the grid label by using text at the center. So grid center, this is the code, label, sequence length, and now grid center 0.8 called blue. So it will create 1, 2, 3, 4, 5, 6. So we have 6 grid for 2x2 degree grid for Peninsula Malaysia. Okay, now I will show you how to prepare 0.25. For 0.25, the same thing. We will need library lattice, raster vis, and then we read our DEM, our elevation map. So we put our DEM in this working directory, which is our folder. We put our folder here, and our DEM is located inside that folder. So we read that working directory and then read the DEM, and then we create a 0.25 degree grid resolution. First, we extract the extent of the DEM by using extend function, so that the grid will be only in the DEM that we use. And then we generate a 0.25 degree grid based on that extent. So we will create 0.25 degree. So we use the CRS will be the same with the DEM. So we run this code. Now we populate the grid with dummy data to create visual boundaries. So the values with dummy data. And then we can convert the grid to spatial polygon objects for visualization. So as grid, spatial polygon. And then we plot the DM, and then we overlay it with the grid that we created. So we have this is the main title, which will be 0.25 degree grid on DM Peninsula Malaysia. If you want to change the title, you can change the title here. So I make a plot here. So it will plot the DEM. So the DEM. But where is the plot? The grid. So the next code will plot the grid, overlay it on the DEM. So I run this one. See it overlaid. So if I want to put the grid label, I can run this code down here to grid label. So you can see I can grid center, and then I will put the text. So you can see how many grid is there. There is 440 grid. Now, if we reduce the resolution to 0.25, from here you can calculate how many grid is there for Peninsula Malaysia. Now I will show you how to prepare a more finer resolution, which is 0.05 degree. So here we will use the same library, which is library lattice, raster, and rasterviz. And we set our working directory and read our DAM. So our working directory just now is here, this folder. This is our working directory. And then our data DM is this one. So it is inside this working directory. So folder address. So run your folder address, set working directory, and run your DM. And then now we create a 0.05 degree grid resolution. But first we need to extract the extent of the DM. So this is our DM just now, but we need to extract the extent of the DM so that the grid will prepare inside that within that DM only. You run this one. Now we generate a 0.05 degree grid based on that extent. So the resolution will be 0.05 and the CRS will be similar with the DM. So we generate the grid and then we populate the grid with dummy data to create visual boundaries. Now we convert the grid to spatial polygon object for visualization. We use spatial polygon. And then we plot the DM, the DAM, and overlay that with the grid that we prepare. So we plot the DAM that with this title, 0.05 degree grid on DM for Peninsula Malaysia. Terrain colors is 100. So we have plot our DAM and overlay it with our grid just by running this code. Now it's take some time because there's a lot of grid, but it looks faster now. Yeah, this is 0.15. This is just optional. If you want to plot the grid number, you can run this code. If you want to calculate how many grid is there that you already prepare, right? So you can run this two of this code just now. And then it will show you, but it is very small. I don't think it is there anymore because it's very, very small. So I don't think we need that information. So we don't need that one. So now you have this different grid, more finer resolution, 0.05 degree grid. So this code is just for you to play around with your presentation or sometimes even for your own research paper, just to show the different grid of different resolution of the data set. If CMIP6 looks like this, final resolution looks like this, and when we downscale, it's even finer resolution. You can do even for basin scale study. So thank you for watching.